Hi, good evening.
Good evening. Good evening. Good evening.
So, how is your business going on, Kaushik?
What's going on?
Vivek Kumar, you are coming first time. Mr. Vivek, you are on the mute.
Hi.
Hi. Yes, Vivek Kumar, can you introduce, please?
Yes, myself, Vivek Kumar. I have 13 years of experience in static equipment design.
Okay. So, you recently joined the group, no? Right?
No. I was there earlier and I attended few sessions also earlier.
So, you are working in static equipment. So, you have any particular issues to discuss here?
No,
Nothing.
not right now.
Okay. Anybody want to discuss any issues?
Anybody do FEA on their own? Is anybody?
Vivek Kumar, do you done any FEA?
No, not me.
Neeraj Pandya? Anshul, I think we didn't done anything. We just reviewed the FEA documents and that one, but we're not done first ones by hand. Yes.
I have reviewed recently, and I think I've done it in the past, like 2.5 years back. So I don't know the details. But what is the question?
No, no question. Actually, for one equipment, we need to do the junction dish to skirt junction analysis.
Okay.
So, anybody done it prior?
No, that can be. I think it's
That
not.
is analysis.
Means it's not complicated. It's just we have to model in FEA, right? Anshul, I will correct me if I'm wrong.
Yes,
We have to model in the FEA means ANSYS and that software. Then we have to provide the what material we are using, and after that one we have to apply the loads where it's what are the loads coming. That's this is the basic concept I know about FEA doing on that one. But after that one, in depth I didn't know.
I think that is hot box analysis, right?
Yeah.
No, it is not hot box actually. Hot box will come when the temperature is very higher.
So not a thermal analysis.
No.
Then it's very simple, na?
Very simple, yes.
Yes, you just have the phase mesh near the junction, and
Yes.
refined meshing near the junction, and you
Phase
have the
mesh, yeah? No. I think we need to do the 3D modeling.
No.
Yeah, 3D modeling is done. Face meshing means just there are different kinds of meshes are there. Means fine mesh is there, the raw mesh. There are 3-4 types mesh are there. Means it analyzes when we select the fine, it will very minute. It's different stresses is.
Okay. You mean that that particular region we can do the meshing?
Yeah, you can refine the mesh. You can have the element size smaller there, so that more equation will be generated there for convergence point.
How to, what type of meshing we need to select? That there will be different types of meshes, no? So
yes.
It is
Normally, it's fine type meshes will be selected because to get the accurate answer and that one.
So we need to select that area of that junction, and then there we need to say, we need to say that fine mesh in the local area, like that we need to give.
Yes.
Yeah. Okay.
That also can be done, and also complete model also we can do with fine mesh and whenever we.
No, but complete model fine mesh, what happens now? Then it will take more time for the.
Yeah, to analyze and run that program, it takes some more time.
Yeah, and one more thing, one more question is the what is called. See, when you give a very fine mesh, the result will be accurate, but at the cost of the more time for the analysis. So, how to that convergence? How we can do it? Anybody having experience?
No. The size of the element that will result in a perfect result with less time, you can only have that with experience.
No, but is there any convergence? Something. Earlier I think first we will start with some size, then we will reduce the size, and if the results are not varying by more than 10%, then solution convert something like that. Is it still applicable or? in the industry it's a different how it is done.
Yeah, still it's applicable because that only the wave how we're going to reduce in that one, the whatever we selected.
Yeah.
So 10%, we'll keep
Yeah.
reducing, and then we'll see that results in that one. Fine meshing and that one, it will be even if you analysis not take more time, maybe 5-10 minutes we can wait to analyze, and raw meshing it will be maybe within seconds it can be give the results.
Yeah, meshing it will be faster, maybe but I think only analysis only. I think it will take. Sometimes it will be more than hour.
Not goes to hours. If model is very big, then it will take some time. But our only two junctions, that dish and shell. So it's
but I need to model the dish, and then I need to model the skirt and the basting. So
no, but you want to analyze only these 2 points, no, where dish and shell. So you have to model only those 2 points is enough, not to model complete equipment.
No, but if I don't do that, then boundary conditions it will not be accurate.
Boundary conditions, but the loads and whatever you're coming, you have to verify with that point only, not completely vessel wherever it's.
Correct only, but the how to give the boundary conditions. So we need, if you model the base ring, then I can say it is fixed at the base ring, no?
Yeah, you should model the base ring and top ring. But what is the diameter?
Diameter is like I think 4.5 meter.
Yeah, but still it would not take 1 hour.
Okay.
But wherever it's connecting, no, that part only you can model. That's I think.
No, I have seen some reference in the net. So they have modeled the dish end and the skirt and this one.
Okay, means this dish end is the bottom side, not top one, right?
No, you have NCs. Ramakrishna, you have NCs?
Yeah, I have.
Okay, so the NCs support some raw file like dot step or something like that, so that I can help you for the 3D model point of view.
Yeah, 3D model. I am doing it in Inventor.
No, I mean to say I can give you the 3D model in Inventor with your all dimension. It will take less time because you are doing, I believe, lots of hard work for that. So I can give you maybe you can give me the parameters. I can give you and you see the model, and then you if you see in the NCs you have that option like import a dot step or dot something. Then
yes,
you can.
Yes.
I can provide you the model. I can help you on that. No problem.
Okay, sure. I will contact
you separately. You DM me. Then let's see.
Okay.
You got.
And also you can check the analysis on Inventor too.
In Inventor analysis, you can check.
Yeah,
Yes.
I think because they are doing some of our Inventor job. They are telling that in analysis also possible.
No, Inventor also having that facility, but again you have to learn it. I mean to say, you have to prove it that it is giving the correct result. For that you need something to provide.
I think it may be like a quick check. I think it may not be accurate.
Yeah, the Inventor having that option. You can just try to find out. Inventor have that option like analysis.
And you have to provide the material and that one, then it will do the analysis of that one.
Yeah.
There is 2 options in Inventor. One is one will be pre-installed with whatever Inventor software you have bought, and another you might have to purchase it separately. Okay. That part is more accurate than the already installed.
Okay.
It's like Annex has an Astron, na? Similar.
Okay.
Yes, similar to that.
Yeah.
Okay, Ram, you got this one?
Okay. Yeah. Thank you.
So, one question I wanted to ask.
Yeah.
See, I have a horizontal vessel, and saddle height is not that much. It's just 25 to 30 mm more than the bottom nozzle.
Okay.
So, do you guys provide another like a wooden block on the saddle for transportation, or what do you do?
Yeah, anybody want to answer?
Road transportation?
Yes, road transportation.
Yeah, it is well and good if you provide some wooden support below that one. Otherwise, it will be in transportation. It will hit to the bottom of maybe in the some
Because
bumps
yes,
and that
25
one.
mm is way too less.
Yeah, 30
Yeah.
mm is less.
Weight of the equipment?
Weight of the equipment varies. I have multiple equipment and they're ranging from 10 to 20 ton.
Okay.
10 to 10. You can provide a channel also.
Yeah,
What?
channel or wooden,
Extension.
whatever may be, but your bottom to be lifted. The 30 mm is very less because 30 mm in jumps.
Or
and
you
that
can
one.
provide a heat exchanger transportation setup.
Okay, you're saying provide channel. Yeah.
Instead of wooden, this one, he is suggesting to provide a channel. Means steel material, something, right?
Yes, this.
Yeah.
Correct.
I send it.
So normally, normally you have to give 100 to 200 gap, right, Atul Sharma?
Normally we maintain 100 mm gap from bottom to receiver transportation setup.
So you have to keep that on something to 100 to 150 or something.
Yeah, this is our thumb rule for all heat exchangers for gentle.
Okay, you got your answer.
Actually, how this is concerned to you? I mean, you mean that nozzle will hit? I mean, if the gap is less.
There are little chances, but yeah.
No, but I think generally we keep 25 mm above the saddle base plate. That is good enough, actually.
No, it's
That is?
good enough, but while transportation, we used to keep some wooden blocks or something in
Yeah.
the bottom, not to hit
But
the.
what is the thing now? This is the height of the fixed saddle.
Hmm.
So the customer has sliding saddle 25 mm below less than the fixed saddle.
Then in that case, you need to adjust. You need to put something to have match the elevation.
Yes.
Elevation as well as the height of that one, it should not be hit while in the transportation in
Correct.
some bumps or something comes like that.
Yeah.
Yes.
Okay, you got your answer?
Yeah. Thank you.
Okay, welcome. Any more?
Yeah, I have a little doubt. I did not use it, but when I designed a standard flange as a Girth flange,
Okay.
I have to uncheck the standard flange option or
What,
keep it.
what is your question?
No. Is the Girth flange exactly standard flange?
Yeah, absolutely.
Is there any additional requirement like 3 mm corrosion allowance to be added to the gasket face?
No, anything.
Then no need, na.
It's a standard flange, then why again you have to check? It's a
Yeah.
direct-
If there is
Because
no
I,
requirement,
Your Girth flange is a standard flange, and
Girth flange is standard flange.
okay. So
Then not required actually. You can keep the standard flange on.
yeah,
I think this happens a lot of time
But
when
only
your
the
vessel. Yeah, this happens a lot of time when your vessel is made of entirely pipe. Yes. In that case, you don't actually have to calculate the flange.
Yes. But G-Note, I have
make
to
sure
match with the
make sure that any external loads are there. Those are taken care of.
Yes.
yeah.
You were saying something?
yeah,
Atul,
Tushar.
you were saying something.
Yeah, Tushar.
No, I got it. But one more, I have to match with G-Note with the pipe thickness, or it will take
Yes.
okay.
Yes. You need to match that.
But when
Actually,
I need to match, I have to uncheck.
Yeah, you see UZ 44. So there is a dimension given. So that you need to match. UZ 44 you read.
No, I think he's just talking about the connection point, the thickness at the connection between the pipe and the belt. So you're using the standard pipe,
That's
Yeah, using a standard pipe.
and your standard pipe is having schedule.
Yeah, schedule.
Okay,
Let me
see,
check.
in PVElite you will only have one fixed schedule when you select the standard flange. You can change that G0 value as per another pipe size. It does not make it non-standard.
Okay, got it.
Yeah, because in this 16.5 you can also do that. Na?
Ideally, your flange thickness, neck thickness, and your connecting adjoining the shell thickness should be same. Even if it is less, also PVElite still do the calculation and it gives a warning that
Yes.
so That's right. So to prevent that warning, your flange neck thickness, I mean G0 should be more than your connecting shell thickness.
It's similar to
More or equal, I mean equal to or more.
when you purchase a standard flange, you also mentioned WNRF, then you mention the schedule, right?
Schedule, yeah.
Similarly, you have to mention the schedule.
You match same as your shell. You can also mention thickness also. If you are making from plate also, you can specify thickness.
Thickness of flange.
Pipe. Yeah, pipe and
Neck or you, so we can say you have to specify ID actually. Inside diameter you need to specify. That is more accurate way of saying.
But this flange and this the pipe, the joining, that both thickness to be matched, no?
Yes, that's what. See, when you match ID, this will automatically match.
Yeah, this will automatically.
in a standard flange, OD is fixed, na?
Fixed, yeah.
Yes. ID will change as per schedule.
Yes.
Higher the schedule, lesser will be the ID.
Right. So basically, you need to match the ID of the flange and the shell. That's yeah.
Okay, your pipe and flange ID both should be matched, right?
Match. Yeah.
Yes.
Okay. Okay, Adarsh, got your answer?
Yeah, got it.
Okay. Any more points want to discuss?
Okay, if we are on PVElite, I need to ask something. There is an option in configuration for nozzle load to be selected on the facing, pipe end.
Mm.
That option is for nozzle load to be considered in the flange facing, na?
Yes. Yes.
Yes. And if we do that, then there will be higher moment generated on the junction.
Exactly. Yes.
Okay. And generally, the customer spec provide the nozzle load at the junction.
Correct. Because even the pipe stress analysis, when they do it, they'll do the analysis. I mean, those loads they will find out the stresses at the junction.
Yes.
And that stresses they will. Yeah. So it is most of the times it is at the junction.
That's why we used to do this WRC on that one, no? And then it will be at the junction. It takes care of that one.
Actually, what happens now? Some people forget to uncheck the option, and most people don't just go to configuration. Yes, most people don't go to configuration to check whether or not this is selected, and in that case, thickness will be more. Required thickness will be more.
Yes, unnecessarily increasing the thickness.
Yes.
Thickness will be more for this nozzle pipe, right?
Yes, from nozzle pipe as well as the shell, local shell thickness might be based on the WRC.
Ravi, here what happens? Normally, whatever the nozzle loads we are giving, they will assume that as if they are acting at the junction. I mean, that is by default in PVElite, but there is an option in PVElite that these loads can act at the face, at flange face. Then what happens? Due to your longitudinal movement and force and this circumferential force, they will create additional movement, that force multiplied by your height of the nozzle. So that movement extra will add.
That actually we used to do in this derating and that case, no?
No, it is derating. It is for both the cases. Only it is about additional movement will be added because of this. I mean, if you don't uncheck this option, that's right.
Okay.
I think you didn't understand.
Yeah, I got it. But this additionally, this movements and that will adds when you apply the forces on the flange face, right?
Correct. Yes.
Okay.
Yeah.
So,
but that is not required unless client asks for.
Yeah, normally we do at the junction only, the WRC whatever given in their spec, client spec, they provide maximum this load to be applied. That directly we are used for the junctions only. Will not apply
because some special scientists will be there in client side. So the time this happens.
Okay.
One more thing.
Yeah.
In PVElite, is there an option that we can have a different specific gravity for hydrotest?
I
No.
don't think.
I think no. So we don't have a separate one, but one only we can provide, and that if you
I
want.
mean, it takes by default one. So I
Yes,
think
it takes by default one water hydrotest.
Yeah, why you want to do it with different with oil or
Yeah.
something?
Actually, the customer spec says that you need to consider the static head of has the more density, be it the operating fluid or the water.
So then water will be always more, no? Operating
No,
fluid. What is operating fluid use?
Sometimes operating fluid will be heavier, but
What is your operating fluid? Then you have to check. Then if your operating fluid is more heavier, then you can add that one. Or else oil and gas normally we use water only. That's because oil always
Yes.
is lighter.
no, or otherwise until you tell him, otherwise I will increase the pressure.
There is one more option. I think there is an addition of static head. Like a certain amount that needs to be added. We can, I think, put
Yeah.
that value also.
You can try that.
In liquid, adding in the liquid, that option we can add this additional what you want to.
No,
During the hydrotest, no. So yeah, you can try any.
Okay, Atul, this question is for you. In heat exchanger, you have horizontal heat exchanger, right?
Okay.
Horizontal, vertical. On that, do you consider the nozzle height in PVElite for hydrotesting?
Nozzle height.
Like, projection of the nozzle outside the vessel.
I always model PVElite as per the my proposition height. So in the hydrotest, the proposition is also always height mentioned in the PVElite.
No, I think actually there is an option in PVElite. There is option of nozzle projection from the from vessel to the top and nozzle projection from vessel to the bottom.
Okay. Bottom and left and right. There is 4 options, I think.
Yes.
We are careful. Yeah, for horizontal we use first 3, the 250 mm, 250 mm, 250 mm only.
Okay, so you add that.
Yeah, normally used to add that one, the projection in that one.
Yeah, normally for horizontal only.
Horizontal as well as vertical also we used to add that one.
Yes.
No, our senior says vertically we don't have to add.
Okay.
But normally in our case we used to add this projections and that one.
Yeah, so I did the same, never got the same result manually and PVElite.
Uh-huh.
Yes. Like hydrotest, slight difference on manual calculation and PVElite calculation.
Why it is maybe some formula different you are using or something?
I don't know. I mean, I inserted the projection accurately, but I think I experienced that for 6 or 7 vessels. So it was coming more on the PVElite calculation. So I left it as it is.
Okay, Atul, sir, why you are not adding in vertical, Atul?
No, we did not agree because we have the guidelines from the private clients also.
Oh,
You don't have
okay.
to
Due
add.
to that guideline, you are not adding. Okay.
Yeah.
So Anshul, you got, means normally we need to add. So
Yes, okay.
Ramakrishna, you are
Where is that option in PVElite? Where?
Just a minute, huh?
Yeah.
This is a design consideration. Below, above the MDMT and below the filled hydrotest vessel.
In design conditions, MDMT.
Should I share my screen?
Yeah.
Think just a second, huh?
Or 1 minute. I will share my screen.
I have an older version. So do you have the latest version?
Yes. 1 minute.
Okay, then you should.
Yeah. Tell me. So where is it?
Design input. Can you go to the hydrotest option? Scroll up. Scroll up.
Scroll up.
Okay.
Yes.
Yeah.
You see
We
the
are
projection.
400,
400 and 300.
Yes.
Yeah,
Okay.
that is.
Projection from top and projection from bottom. Okay.
Yes.
Okay. You mean it is a topmost nozzle projection from the OD?
Yes.
I mean ID, and
The top position of the vessel, and above that you have this projection.
okay, and this projection from bottom opening. Okay, what is this? The flange distance to top.
We never select fourth one. But first three we have to select same values
No, this is projection from top, I understand.
from
Projection
top.
bottom, I understand. Then projection from bottom opening, what is it? Third one?
Third one I have not used. Can you just F1 it?
Projection from bottom opening. Enter the projected distance of the nozzle from the outer surface of the vessel to the face of the flange. The distance is used to calculate MWP of ANSI flange when it gives MWP if the engine is okay.
Operating and
And
Okay.
enter the nozzle from outer surface to the flange when the tendency is selected for hydrotest line. Okay.
The first two are generally used. The third,
Yeah.
most will not let standard flange govern the MWPs.
Okay. Yeah. Thank you.
Anshula, Ramesh, got your answer?
Yeah,
Okay. Any more issues want to discuss?
100% nozzle load to be transferred to the vessel support.
Yeah, actually, the same thing I also want to raise actually. Actually, it was not required.
Yeah, but these days most of the customers are asking for this.
Asking?
Asking, I mean, the sense I had them written.
Okay.
All vessels shall be tested. Yeah, Atul.
yeah, there is an option in configuration setting.
Yeah, the option I know the option. It's just I shared. I think I shared the yes.
I think it is better to put 50%. I think instead of 100.
Yeah, but client is asking put 100%, then if we can add that.
Yeah, if we say it is required means we will do it. But only thing is foundation will be huge.
Yeah,
Even for a small vessel also they need to put piling.
double the foundation would require. If the small vessel have like large nozzle, then it came over for it too.
Yeah,
I mean, I was
my civil person is saying, you see, same vessel, both are, one is big and this is small. For both are, I am putting piling. Client will ask.
You can inform client that one. If you add that one, then your cost of this foundation will be increases. So
Actually, it is not required. Actually, it is unnecessary.
actually it we used to do for a large vessel,
Yes.
but now they're asking for smaller vessel too. They're not required.
they follow maybe same the whatever the large vessel the experience. Yeah, on the small vessel also.
Because actually I was getting a negative value of the saddle load because of this. They will share the same of the group.
Negative value?
What is
Yes.
You mean some nozzles are acting downward? I mean, some loads are acting upwards.
Yes.
It is facing compressive instead of tensile.
I mean, in the nozzle, radial load is always upward, na?
Yes.
Excellent.
But actually you should design. They say you should check for both directions.
Positive, I have no issue. The negative is the one where it is failing because pedal has no load to bear itself.
Yes.
So the requirement for the anchor bolt was more.
If you go into that direction now, then it will be a big topic. I mean, your longitudinal in one direction, and when it acts opposite direction, what happens? All those things, all that combination we need to consider.
Yes, and to be honest, I have not clearly understood how the PVElite is calculating this. Because
I checked. Actually, it ignores the movements. Okay. Only it consider the forces, and it will resolve into the vertical direction and horizontal direction, and that's it.
Because I once tried to do it manually, and the nozzle load on the saddle was coming more than what was coming based on the calculation.
No, I had this issue, and actually our vendor was saying he was skeptical. Means PVElite, I don't know how it is doing. This is not correct. Something like that he told. So then I I have done in Excel calculation. It was perfectly matching. PVElite doing correctly.
No, actually, I considered the movements also. I resolve them into force, then again into movement.
No. PVElite clearly says that it will not consider movements. Movements will be ignored because it will be locally. Locally it will be mitigated. That is the assumption.
So only forces will be considered. So
And how can you resolve the movements? That is also difficult. No, you cannot do it.
It was very difficult, but
Very difficult, and even if you do it, also it will be a mistake. I think you could, unless you do FEA, you cannot exactly certainly say what happens with the movements.
So Anshul, you can try with only the forces, then maybe your manual and maybe PVElite comes the same.
yes, I have to check that.
See, but you see, when you take the forces, check in what direction the loads are applied. I mean, when in the PVElite model, it will give you the direction.
Yes.
When you apply the load, okay, you see in what direction it is there. Means, I should say, when a nozzle is at 0 degree, this direction will be different. When the same nozzle, when at 180 degree, the direction will be different for the longitudinal or your whatever transfers. So that part you need to see, and then you have to carefully see which direction it is there, and accordingly you need to resolve the forces. Then it will come correctly.
Okay. Suppose.
Hope you understand.
Yes. Suppose my vessel has two nozzle at top, two nozzle at bottom, and one nozzle at each side of the dish end. Same size. Same nozzle.
Yeah. So it will not
The
be.
forces cancel out.
No, yeah, you need to consider the direction. 1 minute, let me see if I have any horizontal vessel. We having right now.
Because if we go into checking or changing the direction of each and every nozzle, then suppose I have like 20 nozzles on a vessel, it will be difficult.
Yeah, that's why he's
I think you default whatever PVElite is taking that direction only you need to check. I think that's why I told, if you want to go with all the combinations, it will be.
It will not be possible.
Possible, yeah.
okay. You got your answer.
See, the PVElite is clear. I mean, which direction it is considering, you see that model, you will understand. It will show the direction. Means radial, which direction it is considering, longitudinal, which direction, circumferential, which direction it is giving. So accordingly, you need to do the summation. Then only it will come. I verified, and PVElite is doing perfectly this.
So better Anshul follow with PVElite, not to try with manual.
I'll check tomorrow.
Yes.
And can you provide the dummy native file of this failure? I can work on it.
Are you asking me?
I am asking, can you provide me with this failure native file copy?
So he will try like that.
PVElite, no?
Yeah. I can work on it.
Okay, I'll just make one on my personal laptop and then I'll give you.
Okay.
Yeah, I think I wanted to ask one more thing.
Keep on next.
Yes, sir. Have any one of you ever worked on MAT curve, CET curve?
What is CET? It is called.
It is critical exposure temperature curve. PVElite also says MDMT in bracket CET, minimum design hurdle temperature. That is not the CET I'm talking about. It's critical. It's the temperature that your equipment will experience in relation to the pressure because of the fluid. Like some fluid freezes at the 0 degree Celsius, 0 bar pressure.
Okay, you are talking about depressurization.
Differential pressure.
No.
Yes.
It is called depressurization. So that we need not worry, because process when MDMT is given, they will consider that depressurization and they will give it.
No, actually, in one of our case, it was left to the vendor that MAT, minimum allowable temperature, shall always be lower than CET, critical exposure temperature.
More than or less than?
Less than.
Yes, less than. Yeah. Yeah, that is obvious, no?
Yes. So, for the minimum allowable temperature, we provided the calculation of reduced MDMT.
Okay. Okay.
The final MDMT that we can have based on our thickness.
Mm-hmm.
And its lowest value should always be higher. Its lowest value should always be lower than what customer has specified for the 0 bar gauge.
No, I don't understand what is 0 bar gauge and all, but see,
Okay, so suppose
see, MDMT, MDMT for the vessel will be decided by two criteria. One is your local environment condition, that is one, and second is your process condition, that is nothing but depressurization. When suddenly if your pressure drops to a certain extent, then your liquid will flash and it will reduce the temperature of the vessel. So that how much will be, it will be calculated by process department, and based on that they will specify the how much MDMT.
But actually what we received was minus 45 degrees Celsius MDMT and CET at minus 47.8.
So I mean MDMT was wrong then. MDMT they should have specified minus 48.
And when I Google it, I actually found that there are cases when they do that. Because they don't want minus 47 to require another additional material. That is not CS.
Oh,
because so they do that because even at 1 bar pressure, the MDMT will go from minus 47 to minus 20, minus 15, like that. That is why they have created this CET and MAT calculation. Compress software has this as an inbuilt system. Like if there is an API 579 code defines this MAT and CET, and based on that you can calculate that.
Okay.
But as far as I have understood, I think MAT is nothing but reduced MDMT.
The minimum allowable temperature is nothing but MDMT, no? MDMT. Which the vessel can accept. That is MDMT. MDMT designed versus MDMT specified. Your CET is nothing but MDMT specified. So it is cold. I think it is CET is coldest expected temperature. I guess. I think CET.
They are defined as critical exposure temperature.
Okay. Anyhow, meaning is same.
Yeah, meaning is same.
Yeah.
The coldest temperature that the equipment will
Yes.
have. Just wanted to know whether or not anyone has done that.
No, but I will find out. I will check. Yeah, what was your material? SFINC grade 60?
70.
Yeah, 70
yes,
also. Yeah, 70 also is okay. I mean,
70 and that too normalized and impact tested.
Impact tested, yes. At minus 48, no?
At minus 46 as per their requirement.
Okay. Even lower than that?
Yeah.
Yes.
Okay.
Calculated or designed MDMT, it's coming at minus 49.
Okay.
Lowest,
okay.
Yeah, and that is of standard flange.
Okay.
Can we continue maybe in the next session, this one? Or
Yes. Yeah, we can close, I think. It's
okay. Can we close or any?
Yeah, we can close, I think. Yeah.
Okay, Ramakrishna, if you find anything, you can share, Anshul,
Yes.
and we can discuss this. Continue on the next session also.
Yes.
Okay. Thank you.
Okay, thank you. Good night. Bye.
Good night. Bye.